Hello team, it's Arun Singh here and welcome to back in my new video, Chain of Responsibility. What is Chain of Responsibility? If I will just go and see the name, it is saying I have a chain and I have a responsibility. That means I have a particular chain and each part of chain is following some responsibilities. I'm taking an example from mechanical engineering where I have to create a car and where I have a chain where I'm particular point I'm adding the tire, at particular time I'm adding a color to the car, at particular time I'm adding an engine to the car, and at the end result is I'm getting a furnished car. So that is the live example of chain of responsibility. Let's see what theoretically we are getting from it. It follows category of behavioral design pattern, that is offers solution to problems that happen in the communication between separate parts of the code. Why it is a behavioral design pattern? Because we are talking about communication between separate parts of the code. When I'm decoupling the responsibility, my objects need to communicate. So that's why it follows a behavioral design pattern. Chain of responsibility is a design pattern where a sender sends a request to a chain of objects, where the object in the chain decide themselves who to honor the request. If an object in the chain decides not to serve the request, it forwards the request to the next object in the chain. If I'm creating a car, then the objects in the chain will decide that I will add a tire to this car, I will add a color to this car, I will add engine to this car. That is, each object in my oops will have if condition where I will decide whether this condition met. If this condition met, I will do my responsibility, else I will delegate request to the another object in the chain. Responsibility is outsourced. That is, in a chain of objects, the responsibility of deciding who to serve the request is left to the object participating in the chains. If I am an object and I am participating in chain of responsibility, I have to write an if condition. No one else will give this if condition to me. I will decide whether I will participate or not. When to use this design? If multiple objects can handle a request and the handler doesn't have to be a specific object. Let me give another example. Let me take an example of ATM. There I have basically different type of notes. I have 10 rupees note, I have 50 rupees note, I have 100 rupees note, I have 500 rupees note, even I have 2000 rupees note. But ATM can only dispense with 2000 rupees note, 500 rupees note and 100 rupees. So now I can just delegate or decouple this problem into different objects. One object will dispense 2000 rupees note, one object will dispense 500 rupees note and another object will dispense 100 rupees. So here, how many number of 2000 notes are there? That is totally depend or totally handled by one object. The counting of these 2000 rupees notes, whether they are sufficient or not, whether there is number of amount we have to give or any logic we want to put about the 2000 rupees note. That if I will dispense 10,000 rupees, I will give 2000 rupees note. For a particular period of time, bank has put in some policy. So I'm just going and focusing on that 2000 rupees note object in my chain of responsibility. My other objects can rely relaxed. A set of objects should be able to handle a request with the handler determining at runtime. At the runtime only I have to determine whether I will give 2000 rupees note, 500 rupees note or 100 rupees. Why I'm saying that? Let's say I don't have 2000 rupees note and you have asked for me 3000 rupees. So in this case, definitely if I have 500 sufficient 500 rupees, I have to complete the request. So I will give 2000 rupees note, and if I have sufficient 500 rupees note, I can give that particular 500 rupees note. A set of objects should be able to handle a request with the handler determined at runtime. Now, structure of chain of responsibility. Here I have parent class and here I have handler 1 and handler 2. These are the child classes of parent class handler. Now, if handler 1 or handler 2 can handle that request, fine. Else they will delegate a request to the parent class that is handler. There can be some specific condition where even parent handler cannot delegate the request. In such condition, you have to handle this by your code. That if even parent handler is not able to handle the request, then what you need to do? How to decide that? Whether you will throw an exception or handle it logically. Let me give you an example. The same ATM example I have. And I have entered that I need 5,552 rupees. Now, this input, since I have more of 2,500, so why I should take this amount, 5,552. So at the time of input only I am putting that condition, that node should be multiple of 100 at least. Now, if I have put it that condition also, and I have added that I need 5,000 rupees note, and I don't have sufficient amount in my ATM. I don't have 2,000 rupees note, I don't have 500 rupees, even I don't have 100 rupees. So now, if you have even 100 rupees note and class is not able to disperse that complete request, you have to handle it. Structure of chain of responsibility, where handler is an interface for handling requests, and client it sends a command to the first object in the chain that may handle the command. Now let's see a demo. In demo, I am going to give two demo of this design pattern to make it understand completely. Thanks for watching.